Hello everyone, in this video we'll see a coding interview problem. This is a example program for a flood filling algorithm also. What this algorithm is and what the problem is, we'll see. This is the problem. We have one grid and we have several cells in this grid, and each cells carry some colors, and the respective numbers I have written in a separate table. So this blue color stands for 1, and this dull yellow stands for 2, and this green stands for 3. So what the problem is, I'll be given one cell. If for example I'm picking this cell, and I have to travel in all 4 directions, and I have to make all those adjacent cells to the same color. For example, here I have this green color. In case I'm filling this with the cyan color, so I have to fill all these cells. This is a boundary. In a real world example, you can see that it in a paint application. Here you have the 3 rounds, and this black line is literally a boundary, and I'm picking this paint bucket tool, and I'm choosing some other color, and I'm replacing. So all those white pixels are replaced by the new color. This is the same thing this problem does. So I have this green color. When I replace this with this cyan color, so my table will become like this. So all those neighboring pixels will be switched to some other color. You can notice this here, the same color is there here also, but there is no way to reach this cell, this column. So that's the reason it remains the same color, but here all the adjacent in 4 different directions, somehow up, down, and left or right, you can reach. So how do we solve this problem? Here you're using a flood filling algorithm. So flood filling algorithm is nothing but it's like a flooding everywhere, and these pixels are filled. That's the reason it's namely as a flood fill. So when these kind of problems comes, the same task, once you have the cell, you're seeing the adjacent cell. Once you travel to the top, the same adjacent cell you're looking. So the same operation you'll keep on doing. When you reach the boundary, and you'll be halting that process. So how do we do this is, we have to use some recursive algorithms. If you don't know what is recursion, you can check out our other videos, so you can make a good understanding of why the recursion is, why the recursion triggers, and when to end the recursion. Here in this case, why we are recursion is, the problem is a subset. Keep on is repeating, so we no need to rewrite that. There's always next condition for each cell. We can't write, so we make use of the existing program itself by changing just the boundaries. And when you have to end the boundary is when this color is nowhere relevant to the pixel that you are supposed to replace, then you have to end it. And this boundary of this cell, or the boundary of this table also, you should know, which is nothing but the row and columns. So how do we do this is, I'll switch back to the Visual Studio Code. I define this as row and column as defined. I'm keeping this row as R and as defined, column as C, and I need a function. First I declare all those variables. I need int a as an array, and R and C here, and I need a position, so R and C, and I need a new value. For that I am giving v. So for int for R, and here inside of it for int J and C times. So C in A of I and J. And next is you have to get at which position you have to change R and C and V. Next you have to write the algorithm. Here I'm writing as algorithm as void flood fill. You need that array to be passed, so int A. Here you can declare it as R and V, and next you have to pass this current row and current column, and you need to get the previous color and current color. You should have some basic conditions. First, check out the table boundaries I need to check. And next if is for um, don't touch the unwanted pixels. Don't touch unwanted pixels. Here in this example, you're just doing only with this green pixel, not with this cyan or yellow. If this is nowhere relevant to you, then you should not touch. So what I'm doing is I'm writing that condition also here, return. If it is not there, you have to return. And one more is if you are reached already replaced, then you no need to touch it. Already replaced. These three conditions you need to return, which means I no need to proceed further. I can just end it. So what I'm doing is my R current row cannot be less than 0 or R greater than capital R, greater than or equal to capital R. Since we are starting from 0, I'm giving it equal. Or C cannot be 0 and C cannot be greater than or equal to capital C, which means the total column. Okay, and here we no need to touch this, means A of R and C. If it is not equal to previous color, then we no need to touch it. And if it is already a previous color, then also we no need to touch it. Equal to current C, then R and C. Okay, now we are assigning the actual value for this one. Here now current C is a new color. Here R and C. Now I have to trigger the recursion. Now here you have to return. These, I hope you understood this base conditions. First, if it is goes beyond the table, like -1, -2 and all not possible, and after this also is not possible. So I'm terminating those conditions here in the 7. And next is I should replace only this pixel, not these pixels. In Paint also you can treat this black line as boundary, right? So no need to touch the other pixel. If it is not as previous color, then you have to return. And the next one is, if I'm solved this subset of problem again, I should not come back from this cell. Also I may come downwards, so this cell again and again it will go, so it will go to infinite loop. So that's the reason I'm giving it as, if it is already the current one, you should return it. You no need to proceed further, or else we have to replace that color. Then after replacing, from this cell we have to trigger in the 4 different directions, which means can take this cell, the tick mark the cell. Here, just erase everything. And here I'll delete this line. First I replace this color Here my task is done. With these condition, my task is done. I have to go to the right and left, top and bottom. So top condition, how do I write this is the same row. From this row I'm moving one row above, so row minus 1. If I come below this, then row plus 1. If I go right side of it, then it is column minus 1. Then left side if I go, then minus 1. Right side I go, then plus 1. So literally I need to go in the 4 different directions. So from here, above and below. So I need to write 4 statement. Here you can solve this problem as a comma or. So I'm going one row above, so minus 1, but you're in the same column, so C. Now the previous color and the current color you have to pass. Then I told you how to write it in the 4 statements. So next is you have to travel below also. So I'm staying in the same column, but one row is incremented. So I'm coming below. So I'm incrementing it as 1. The next is right and left. Here the row is same, but column is one column prior. So minus 1. And here when it comes plus 1. So here minus 1 and here plus 1. So this is the total algorithm is. Hope you understood this one. This is above and this is below and this is left and this is for right. Each time recursion triggers, and if it is reaches near the boundary, it will check and it will not at all proceed further. And other condition also we just now we saw. So I'll just print it for int. This is R, and inside of it for int, and here J and J, here C, here also J. C out, A of ing, here is giving on space, and here C out, indel. Before that we have to call this method now. Flood fill, how to pass that array A, and since it starts from 0, R minus 1 and C minus 1, and you have to print the previous pixel, means A of R minus 1, C minus 1, C minus 1, and the new one is literally B. Now here the value is B. So we run this program. Before that I'm just checking everything. I defined that R and C, and flood filling I'm passing this array and current row, current column, the previous color and current color. I'm checking these boundary conditions first, and if it is not matching I'll return. Then I have to check if it is unwanted pixel. That time also I'm not working anything, and if it is already the pre-placed one, so no need to proceed further. Okay, return. And this statement is if I'll replace it and I trigger the recursion for above pixel, and next is below pixels, and right pixels and left pixels. Now in below lines I have R and C declared at the above, so no need to get, and here I'll get this in array format, and this is but from what pixel it should start. You have to give this coordinate, so it starts from 0, so I have to give minus 1 here itself. So R and C and the new value. Here I have to call this function A and R minus 1, C minus 1, and what the previous pixel is, so R minus C minus 1, and next new value and then I'm printing that. That's it. Okay, I have sample input here. I'll copy this. Copy. Here I'm going to replace this 2 by some other 5 number. So I'll run the program. Copy paste. Here you can notice this all 2's are replaced by 5. Here you can see this path. Hope you can. This is the path, and this is will be replaced, and this sample. Hope you understood this problem and solution. And this is a super simple problem, and this is one of the example for recursive algorithms also. And this flood filling algorithm is a frequently asked interview problem, and you can prepare it. So thank you for watching, and we'll meet in the next video.